So what's good, TMG fam? It's your boy Ellen. I'm back with another reaction. How y'all feel? Welcome back to the channel. Salute. Now, one thing you've been taught, or I can't assume y'all have been taught, so let me speak for myself. I've been taught since a little kid, since a youngin', respect your elders, right? So when it comes to Voyagers 1 and 2, I gotta respect my elders, bro. They've been on a mission out in space longer than I've been alive. Longer. So I gotta show them some respect. That's why I keep showing them love. All right. And this video here is Voyager 1 has made a frightening discovery after 45 years in interstellar space. All right. So we're going to check this one out. If you're new, hit that subscribe button. You know what to do. Let's check it.
In space travel, NASA's Voyager program, the two space probes that gave the program its name, left our blue home planet in 1977 to give us an insight into previously unknown worlds. But that's not all. Voyager 1 and 2 are still in operation and have now accomplished something that no other man-made object has ever managed before: the advance into interstellar space. What milestones the unmanned spacecraft have already achieved in the last 4.5 decades, and what amazing discoveries humanity's most remote outposts have made recently. We'll show you in today's video. Excited about the groundbreaking discoveries and fascinating spectacles in the universe? Then remember to subscribe to Simply Space and click the bell for regular updates on these exciting topics. By giving us a thumbs up, you're motivating us and showing that we can keep you engaged with the content of our videos. The beginnings. 15 billion miles. This is the huge distance that now gapes between us and Voyager 1. To put that in perspective, that's 156 times the mean distance between the Sun and the Earth. Only one other man-made object has advanced comparably far into the cosmos, and that's Voyager 2, which is currently separated from its terrestrial home by about 12 billion miles. In 1977, no one could have imagined that the launch of the Voyager program would mark the beginning of one of NASA's greatest successes.
1977. Yes, I have to respect my elders.
If it had gone according to the original plans of the experts, the spacecraft would have ceased operations decades ago. But everything was to turn out quite differently. The first spacecraft to leave Earth was Voyager 2, which set off on August 20th, 1977. To explore previously unexplored worlds. Its twin probe followed 16 days later on a different trajectory. To understand the background of the rather broad mission objectives, we have to consider the state of knowledge in the late 1970s. Because actually, at that time, still quite little was known about the outer members of our planetary system. Among other things, the Voyager probes were to study the atmospheres of Jupiter and Saturn and investigate.
See, this is why I wish I knew somebody who was present during that time back then when these missions were going out. So I could just sit and listen to how the times were back then. You know, what was everybody's thought process? What were they doing? Did the world stand still for a second when these Voyagers launched? Were we even aware? Were we paying attention? Were we present? You know what I'm saying? Like, I could sit and listen to somebody talk about that all day.
The geological composition of their moons. Furthermore, all planets and their natural companions were to be investigated with regard to their sizes and masses. But the goals for Voyager included the investigation of different magnetic fields, as well as the analysis of charged particles and plasma given to the spacecrafts on their way. At first, however, the undertaking was unlucky. Communication with Voyager 2 did not work as planned. Fortunately, scientists succeeded in getting the problem under control in time, so that nothing more stood in the way of the exploration of our planetary neighbors. Unexplored worlds. The first task was to take a look at the Jupiter and Saturn systems. As part of this, the two spacecraft performed extensive measurements and transmitted numerous unique images towards Earth. The probes took our understanding of the mighty gas giant and the iconic ringed planet to a whole new level. While it was time for Voyager 1 to leave for interstellar space, Voyager 2's journey still had some exciting stops in store. In spring 1981, for example, a corrective maneuver was carried out so that the spacecraft was henceforth headed in the direction of Uranus. Voyager 2 reached the remote ice giant on January 24th, 1986, which meant that it had already exceeded its originally predicted lifetime twice. On its way to Uranus, the probe also succeeded in detecting 10 previously unknown moons. After the planet had already been extensively inspected, Neptune was to be visited. Originally, this passage was to be the last chapter of the research mission. The approach of further targets was not planned. Once there, Voyager 2 approached Neptune to within about 3,000 miles, taking more than 9,000 revealing images. This time too, new satellites were added to the star charts. The spacecraft discovered 9 previously unknown moons. Triton, the largest of all of Neptune's moons, which was already known at the time, was again to be studied in particular detail. Thus it became known that the diameter of the celestial body is not 3,000 miles as had been assumed, but in reality 1,715 miles. At the same time, it was found that the surface of the satellite has surprisingly few impact points. The brown-white coloration could again be attributed to the influence of geysers. These volcanic formations spew out liquid nitrogen, which subsequently freezes out and falls back onto the surface in the form of white nitrogen snow. Departure into the unknown. In November 2018, the time finally came for Voyager 2 to enter interstellar space, just like its sister probe before it. This star-distant area, which the mighty arm of the Sun no longer reaches, is filled with interstellar medium. Its most important components are ionized, atomic, and molecular gas, as well as dust. Together, these components form interstellar matter. Finally, the interstellar medium is completed by the galactic magnetic field, as well as cosmic and electromagnetic radiation. As the Voyager probes get up close and personal with this remote region, they are making many unprecedented measurements. While Voyager 2 crossed the galactic threshold in 2018 as mentioned, Voyager 1 has been in interstellar space since 2012. Thus, we now have the opportunity to study and compare the interstellar medium at 2 different locations. Consequently, one of Voyager 2's main tasks is to check the data collected by its twin probe for matches and mismatches. Much of the information recorded by Voyager 1 could be confirmed in this way by the second probe. This includes, for example, the density of particles in interstellar space. Interestingly, however, other measurements made by the spacecraft differ significantly. To understand the data collected by the probes, we should first consider the character of solar wind. Around our host star is a dynamic composite of magnetic fields invisible to the naked eye. These lines serve as paths along which electrically charged particles move into the gigantic expanse of space. So, while these particles spread throughout the solar system, they eventually reach the interstellar medium as well. That relic of the birth of the cosmos, which has its origin in the Big Bang and the first supernovae, fills the starry space. However, it's to be noted here that the solar wind and the interstellar medium do not mix perfectly with each other, quite in the same way as also oil and water cannot intermingle. Therefore, the solar winds form a kind of bubble in the interstellar medium, the so-called heliosphere. Thanks to data collected by the Voyager probes, we know that the heliosphere extends some 11 billion miles into space from the Sun. In the outermost regions of this area, the heliopause, interstellar space finally begins. Before Voyager 1 entered the region, very little was known about this cosmic frontier. Thus, the spacecraft was to investigate how the different regions in this threshold region interact with each other, and how much spills over from one side to the other. The findings that Voyager 1 transmitted to Earth in this regard immediately caused raised eyebrows in the ranks of experts. Mysterious interstellar space. The experts had to admit that some of their predictions were simply wrong. For example, the interstellar magnetic field is actually almost 3 times stronger than the researchers had assumed in advance. This in turn leads to the realization that interstellar particles exert about 10 times more pressure on the heliosphere than the theoretical models had predicted. However, the insight that Voyager 1 gave us into the properties of the interstellar medium was also accompanied by a major downer. For example, the instrument used to measure the temperature of plasma has been defective since the 1980s. However, since the corresponding counterpart on board Voyager 2 was still functioning, the experts were looking with bated breath at the findings that the use of the sister probe in interstellar space would provide. Therefore, we now know what really happens when a body approaches the heliopause. The plasma surrounding the structure increases its density, slows down, and heats up. Beyond the heliopause, the interstellar medium reaches temperatures of almost 54,000 degrees Fahrenheit. In this case too, the scientists were wrong. It's much hotter than predicted. However, because the plasma is extremely diffuse and thin, the temperatures around the space probes are surprisingly low. Furthermore, Voyager 2 provided evidence that the plasma crosses from interstellar space into the heliopause as well as in the opposite direction. As Voyager 1 passed this threshold, it encountered compact outcrops of interstellar particles. In turn, its twin probe was confronted with a kind of particle stream that penetrated more than 90 million miles into the heliopause. No less strange was the fact that Voyager 1 entered an area about 800 million miles from the heliopause, where the solar wind slowed down remarkably. The area that Voyager 2 flew through at another place was again completely different. These puzzling differences show us once again how many hidden secrets the cosmos still holds. In fact, we do not even know the shape of the heliosphere. It's conceivable that it resembles less a sphere and more the tail of a comet. Even in the case of the longest space mission of all time, everything comes to an end. It is assumed that contact with the two Voyager probes will break off around the year 2036. However, the exploration of interstellar...
The fact that they can get that far away from us and lose contact, does that not do anything to y'all? Like just, I already think about space just being endless. You know what I mean? But them losing contact like that, it starts to make me like, is there an end? What are we in? What is going on out there? You get what I'm saying? Like, it's hard to explain, but man, the possibilities.
Off around the year 2036. However, the exploration of interstellar space has only just begun. Thus, scientists dream of launching a generation-spanning mission that will give us an even more detailed insight into this mysterious region of space. In the outermost regions of the solar system, the ice giants Uranus and Neptune move in their orbits. While these imposing celestial bodies initially appear to be quiet cosmic giants, in reality, they still conceal many unsolved mysteries. This is not least due to the fact that our remote neighbors have only been visited once so far. Since the passage of Voyager 2, no other space probe has returned to the realms of the ice giants. Despite this, the experts managed to detect some amazing phenomena on Uranus and Neptune, even from a distance. The details of these mysterious spectacles are revealed in today's video. Uranus. The list of the ice giants is not particularly jam-packed. In fact, this squad counts only 2 members, Uranus and Neptune. However, the official designation ice giant is somewhat misleading, because actually, the majority of the planetary material does not exist in frozen form at all. In truth, the celestial bodies consist mainly of volatile chemical compounds such as water, ammonia, and methane.
Ooh.
These substances, in turn, exist as hot supercritical fluids. This special state of aggregation combines the properties of liquids and gases. With an average solar distance of 1.8 billion miles, Uranus is the second outermost planet in the solar system. With a diameter of more than 31,000 miles, the celestial body trumps the dimensions of our Earth by a factor of 4. As a result of the large spatial distance, Uranus needs about 84 years to revolve once around the Sun. During this time, however, the giant planet...
84 years. I just saw a video the other day that said like 26 years to get around its star. 80 something years? That's insane.
It exhibits an unusual behavior. Its axis of rotation is aligned in such a way that it practically rolls along its orbital plane. In other words, it appears that Uranus is lying on its side. The reason for this astonishing axis inclination is, however, unknown. It's commonly assumed that the ice giant collided with a rather large protoplanet shortly after its birth. To explain the present inclination of the Uranus system, this protoplanet would have had to be twice as large as the Earth. Possibly the relics of this galactic collision are still visible today, in the form of 27 moons orbiting Uranus. So it's conceivable that the satellites formed from exactly that material blown off during the collision. Then, a little over 10 years ago, astronomers discovered something strange about the planet. Namely, a massive white spot that graced the uppermost layers of the atmosphere. Thanks to the Hubble Space Telescope, we know that such ominous spots are actually gigantic storms. These whipping formations reach speeds of up to 89 miles per hour and are larger in area than the USA. Furthermore, the methane and ammonia clouds are subject to freezing temperatures. The thermometer here drops to minus 323 degrees Fahrenheit. Just like Saturn, Uranus has its own ring system. While Saturn's orbital composite consists of thousands of individual orbits, Uranus's rings are much sparser and less numerous. Neptune. Added to the star charts in 1846, bluish, shimmering Neptune embodies the eighth and outermost planet of the solar system. A mean distance of almost 3 billion miles gapes between the ice giant and our host star. By comparison, the average distance between Earth and the Sun is about 90 million miles. In terms of their diameters, Uranus and Neptune are quite similar. With a value of 31,000 miles, Neptune is only slightly smaller than its planetary neighbor. In terms of mass, however, the outermost planet is ahead. This amounts to about 17 Earth masses, that of Uranus to 14.5 Earth masses. Neptune takes no less than 165 years to describe a complete orbit around the Sun. The rotation of the celestial body is much faster. In order to turn once around its own axis, the ice giant needs scarcely 16 hours. In 1989, NASA's Voyager 2 spacecraft visited our remote neighbor. Unlike the year.
So see, that's the other thing we got to worry about. With all the talks of us going to possibly inhabit on another planet, right? One thing we have to learn, and I'm pretty sure they're paying attention to that, of course, but for us, for ourselves to think about possibly being on another planet, we have to know the days may be longer there. The days may be shorter there. We don't know. These are the things we got to think about. All these people just hear, oh, Elon's taking us to Mars, but they didn't stop to think of what that could entail of, because everybody just automatically assumes it's going to be just like Earth. It's not. Some of these planets, it takes a lot longer. Some of these planets, it's shorter. A day. Let's just speak about a day. You know what I'm saying? So, you know how it is when people travel and they have jet lag. It takes them a while to get accustomed to it. Imagine yourself having shorter days or longer days. You know? You hear a lot of people go through life and saying, man, I wish I had more hours in a day. Well, some of these planets may offer that. So you might get the chance, you know, or you might not. You know, you might get what you asked for.
Uranus passage completed 3 years earlier, the unmanned spacecraft was able to identify some startling weather phenomena there. These included long, bright bands of clouds in the atmosphere, whose streak-like structures were due to the rapid rate of rotation. In addition, Neptune still holds a meteorological record. In the atmosphere of the planet, storms were observed that reached top speeds of up to 1,305 miles per hour. On no other celestial body do the winds whip faster. Since only little solar energy reaches the planet, the experts assume that storms once developed are practically no longer slowed down. However, this does not mean that the storms may not literally vanish into thin air one day. During its mission, Voyager 2 discovered the so-called Great Dark Spot. The formation, which was interpreted as a hole in the visible cloud cover, was as large as Eurasia. In terms of area, experts were all the more baffled when they simply could not find the Great Dark Spot again a few years later. Why the huge object disappeared is uncertain. One theory is that heat from the planet's core caused turbulence in the atmosphere and tore the structure apart. Speaking of the planet's core, despite Neptune's volatile nature, it is believed that the giant planet has a massive heart. According to current calculations, the planet's core would be 1 to 1.5 Earth masses and composed of metal and rock. While the temperatures in the atmosphere still fall to minus 360 degrees Fahrenheit, the presumed planetary heart beats significantly hotter. Temperatures of nearly 13,000 degrees Fahrenheit are likely to prevail in the center, and the pressure is estimated at several million bar. Magnetic fields and diamond rain. The magnetic fields of Uranus and Neptune have puzzled scientists for quite some time. The invisible forces possess a conceivably unstable character, meaning they are strongly inclined to the rotation axis and deviate clearly from the physical center of the planets. No one has as of yet deciphered the reason for these unusual alignments. It is certain that the magnetic field of Neptune is about 27 times stronger than that of the Earth. In the case of Uranus, however, the situation is completely different. Its magnetic field is even significantly weaker than that of our home planet. Probably the magnetic fields are generated by movements in comparatively small depth, possibly by the influence of ionized water. But this is not the only secret slumbering inside the giant planets. As already mentioned, the researchers assume that Neptune, and also Uranus, have massive cores. These planetary cores, in turn, are embedded in dense layers consisting of hydrocarbons, ammonia, and water. For a long time, scientists have speculated about what breathtaking processes might be taking place under the high pressures at the center. One exciting theory—
I would have thought that some of the planets that were a lot cooler than, you know, Earth or any other planet that's a little closer to its star or the sun, I would have thought those cores would have been cooler. But it goes to show you, even though the outsides of the planet is cool, you know what I mean, the core still remains its core of being hot, extremely hot. So that was an eye opener. I wouldn't have thought it was that way instead of the other way around.
Theory suggests that diamonds may be reigning inside Uranus and Neptune. And indeed, what was for a long time exclusively a thought experiment was proven experimentally a few years ago. For their exciting finding, the researchers used polystyrene, a plastic composed of hydrogen and carbon atoms, to recreate as closely as possible.
That made me laugh because, you know, a lot of these like millionaires and stuff like that, they always get, for a proposal, they have this like rare diamond. What you doing, ladies, if he comes to you with a diamond from another planet? Huh? How many points does that win him?
The conditions that prevail inside the ice giants. The scientists sent 2 shock waves through their experimental substance. In this way, they wanted to check whether the hydrocarbon compounds actually split under the extreme pressure conditions. As a result of the shock waves generated by a powerful optical laser and an X-ray laser source, a pressure of 1.5 million bar was created in the plastic. At the same time, the thermometer climbed to a value of 9,000 degrees Fahrenheit.
Wow.
And indeed, the experiment showed that such circumstances set a glittering diamond shower in motion. As a result, nearly all the carbon atoms joined together to form tiny diamond structures. The diamonds that form in Uranus and Neptune would in turn out much larger than could be simulated under laboratory conditions. After the cosmic gems are formed, they sink leisurely over a period of thousands of years toward the planet's core. Mysterious X-rays. Last year, the Chandra X-ray Observatory detected X-rays on Uranus for the first time. While such X-ray emissions have already been registered on numerous planets and moons in the solar system, the ice giant did not appear on this list for a long time. In the case of this remarkable observation, the general rule held: after the discovery, the real work of research begins. Thus, it was necessary to find out what was the cause of the unexpected radiation. Even if the answer to this question cannot yet be given unambiguously, there are some exciting explanations in this regard. One theory is based on the fact that the spectacle has its origin in the sun. We know that other planets, such as Saturn and Jupiter, scatter the X-ray light emitted by our host star. However, the data collected so far suggests that two other sources of emission are also possible, namely the rings of Uranus or auroras. Until we will get to the bottom of this cosmic mystery, some patience is still needed. Accordingly, we will find the answer in long-term observations. The future deployment of Chandra is expected to produce an X-ray emission map of the planet. In this way, it would be possible to further narrow down the potential emission sources. Consequently, experts would be able to calculate how much of the X-ray emission really comes from the sun, the rings, and the auroras. The natural companions of Uranus and Neptune also show how indispensable future research missions are. In the case of Uranus's moons, Oberon and Titania, it is suspected that gigantic seas hide beneath their thick ice crusts. Neptune's moon Triton, in turn, is suspected of harboring an ammonia-rich ocean. At present, however, future missions to Uranus and Neptune do not get beyond the status of vague musings. When we will again send a probe to the most remote regions of our planetary system is still written in the stars. Despite all modern space telescopes, complex probes, and manned space flights, we are still light years away from having completely decoded the universe. For example, we still do not know the shape of the cosmos as a whole.
It's gonna be a long journey, bro. Like I said, it won't be our lifetime, our kids, grandkids, their grandkids. Like, it's gonna take forever.
And
hopefully we still be inhabiting the planet when we do, you know what I mean?
Structures and entities are hidden beyond our limited horizon of observation. And indeed, even our immediate galactic neighborhood is still full of surprises. Recently, a team of researchers succeeded in revealing the true location of the solar system. According to it, we are in the center of a gigantic cosmic bubble. In today's video, we'll show you the background to this exciting discovery and the topics that keep astronomers on their toes. Galactic Bubble. Basically, the stars and gases that make up our home galaxy are not evenly distributed. This pattern is not only valid for our home Milky Way, but also for the other gravitationally bound assemblies of stars, planets, etc. On the one hand, gravity effects and density waves cause the formation of regionally large star regions and outflows. However, this non-uniform distribution pattern can also be found on a local scale. For example, where two cradles of stars are separated by a comparatively empty space, that the location of our solar system is also in a less densely populated area of the Milky Way has been known for some time. However, the details of the immediate surroundings of our home system were only revealed in the course of a recent investigation. A team of researchers led by astronomer Catherine Zucker of the Center of Astrophysics, Harvard and Smithsonian devoted themselves to this exciting task. Even before carrying out their work, the experts knew that the region lying around the sun is characterized by a low density, a kind of cosmic shell of dust and cold gas. However, the shape of this galactic envelope around our host star was unknown for a long time. The same was true for its evolutionary history and its connection with the nearest stellar evolutionary zones. To get to the bottom of this cosmic mystery, the experts turned their attention to young star clusters, molecular clouds, and stellar cradles located within 1,300 light-years of the solar system. Taking into account the data on position, age, and motion patterns,
Look at that. Hold on, my bad.
Taking into
Sheesh. Distance. You talking about 10, 20 light years away. Just in this photo right here alone.
account the data on position, age, and motion patterns, the scientists succeeded in creating a three-dimensional model of our galactic neighborhood. This reconstruction led to an exciting result. According to this model, our solar system is located almost exactly in the center of a huge bubble, 1,000 light-years in size. The boundaries of this envelope are in turn marked out by molecular clouds and star-forming zones. In this regard, it appears that virtually every known molecular cloud in the vicinity of the solar system is aligned along that very bubble. However, in the course of their work, astronomers also realized that the cosmic envelope is by no means a static entity. Just like the entire cosmos, the bubble is constantly expanding. The experts were able to reconstruct this expansion process on the basis of the movements of the surrounding star clusters and molecular clouds. The rate of expansion could also be determined. Currently, the surface of the bubble is expanding at a rate of 4 miles per second. In the past, however, the expansion may have been even faster. Accordingly, the structure has lost most of its original momentum and has now reached an almost uniform expansion speed. After deciphering the nature and characteristics of the cosmic envelope, another, no less exciting question had to be answered. How did the bubble around the solar system actually form? Explosive birth.
How does everything start with an explosion? You know what I mean? And I'm not, hey, we could possibly be here due to an explosion. So I'm not ungrateful, don't get me wrong, but that's just a question of mine because it always seems to start with some type of an explosion.
Fortunately, astronomers were able to answer this central question as well. From the data sets, it turned out that the 2 oldest star cradles in our immediate environment, 20 million years ago, were likewise in the center area of the cosmic envelope, with the enormous difference that this locally limited bubble did not exist at all at that time. According to this, the structure was formed only about 14 million years ago, at the time when the first massive stars of the 2 areas began to die, in the context of explosive supernovae. You could say these events formed the basis for an explosive chain reaction. Over a relatively short period of time, an estimated 14 to 20 supernovae occurred. The intense radiation, the ejected gas, and not least the enormous shock waves, caused the interstellar medium to be literally pressed outward. Among the most important components of this material, which fills the starry space, are gas and dust. Experts suggest that during the explosive birth of the bubble, nearly 1.5 million solar masses of gas and dust were displaced. This gigantic displacement, in turn, set in motion a process involving several phases, during which intense star formation took place at the envelope's fringes. Using their 3D model, the researchers were able to reconstruct in detail when and in what order the individual star formations that grace the firmament today were formed. However, in view of the elemental processes that took place millions of years ago, one question remains unanswered. Where was our host star at that time? Shouldn't numerous supernovae have severely affected the sun? Fortunately, our mother star was safe during the explosive events. Actually, the sun was still about 1,000 light years away from its current position at that time. Then about 5 million years ago, our host star began to gradually migrate into the spatially confined bubble, so that today it lies almost exactly in the center of the formation. Due to the determined background of the bubble formation, the urgent assumption is obvious that our cosmic shell is by no means an isolated case. If one follows the explanations of the experts, it's much more probable that the supernovae of the past tore many such holes into the Milky Way. In order to verify whether our home galaxy really does resemble a Swiss cheese, the experts plan to track down more bubbles.
Wait. I've never heard that before. Our home galaxy resembles Swiss cheese? Never heard of that before. That's a first for me. If y'all have heard that, detail that saying for me. Well, why did they, where did that come from? First of all, what astronomer made that comparison? I want to know that person's name.
Bubbles in the Milky Way in the future and analyze their backgrounds in detail. Cosmic disinfectant. The fact that complex organic molecules occur not only on our blue home planet, but also on many other objects in the cosmos, is not new information among the experts. In particular, chemical reactions take place in the cold gas clouds of stellar cradles, resulting in the formation of ever larger, complex molecules. Because of this, some researchers suspect that the basic building blocks of terrestrial life may also have come from space. Recently, scientists succeeded in adding another piece of the puzzle to the molecular picture of the universe. For the first time in history, isopropanol could be detected in the gigantic expanses of space. In our everyday life on Earth, this alcohol is often used in disinfectants. In order to clarify the question of whether this organic molecule variant also occurs in the cosmos, The experts are using the radio telescope observatory ALMA in the northern Chilean Andes. With their high sensitivity, the radio telescopes located there are particularly well suited for detecting complex molecules in space. This is how ALMA's antennas came to be pointed at the Sagittarius B2 molecular cloud, since various organic molecules had already been detected in this cradle of stars near the center of the Milky Way. The researchers hoped to score a galactic bullseye this time as well, a hope that was to pay off in the confusing chaos of the spectral lines. The experts actually came across signatures that clearly matched the profile of isopropanol. Using a model that was then created, the experts determined that the cosmic alcohol was formed in the ice of interstellar dust particles as soon as the ice sublimates, or in other words, passes directly from a solid aggregate state into a gaseous one. Certain precursor substances that were previously trapped in the ice come into contact with each other. As a result, a chemical reaction occurs that produces propanol and isopropanol. Puzzling proximity. No other known star orbits as closely around Sagittarius A star as S4716.
Did that not just look like a donut to y'all? Or maybe I'm hungry. Am I tripping? Did that look like a donut?
It's as closely around Sagittarius A star as S4716. In fact, the dazzlingly bright celestial body takes only 4 years to circle the monstrous black hole at the heart of the Milky Way. In the process, the daring star comes within 99 astronomical units of the gravity monster and poses great puzzles to the scientific community by re-evaluating the observational data from the Keck Observatory and the Very Large Telescope. The researchers were able to get a close look at the star in question amidst the elusive clutter of the S cluster. This exciting analysis finally brought to light the astoundingly tight orbit of the celestial body. Meanwhile, the fact that the star reaches a rapid speed of about 5,000 miles per second on its galactic journey is due to the influence of the supermassive black hole. To put this in perspective, this speed corresponds to about 2.65% of the speed of light. In the future, it will be necessary to reveal the unexplained background of this astonishing discovery, because normally stars cannot form in the immediate vicinity of a black hole. The gravitational force of the mass monster would collapse the cold gases, putting an abrupt end to the star birth. Therefore, the star must have originally formed in a more distant region and only later came under the grip of Sagittarius A star. Which process actually brought the celestial body to its surprisingly close orbit is still uncertain at present. The current theories of the experts are that this happened either by a close passage or the effect of a massive formation, which brought S4716 out of its ancestral home and into the vicinity of the supermassive black hole. We are interested in your opinion. What do you think about the exciting astronomical discoveries we have just presented to you? As always, drop us your thoughts, suggestions.
I think there will be no quiz after this video. All right, you know what I mean? This is one of those videos you got to watch multiple times because I'm pretty sure it's a lot of things that went over your head, went over my head for sure. And this is one I'm gonna have to watch again and again to catch a lot of the things over. But man, like the information is just like space, bro. It's endless. Y'all get at me in the comment section. Let me know what you think, man. I'm gone. Peace.